Hey, welcome back, Algebra 2 students. Today we're doing a polynomial review. So the first thing it's asking us to do is find zeros. Now, if it's in factored form like we have here, we have three multiplications, right? We have 3x times x minus 5 squared times x minus 4 squared. Each of the things that's multiplied has a zero if we have an x in there. So we just got to figure out what makes that part 0. So if we plug in 0, 3 times 0 is 0. So that's the first 0. If we substitute a 5 in for x in the second part, then 5 minus 5 is 0. So we have a 5. And then in the last part, we have 4 because 4 minus 4 is 0. So that first one is super easy because it's already factored for us. Okay, on the end behavior thing, remember the end behavior depends on the degree, meaning the largest exponent. So what we're going to do here is anytime we have an odd degree, positive, it's going to have this end behavior. A negative would have the opposite end behavior. If it's an even degree, like any parabola, a positive would be up and up, a negative would be down and down. Okay, so for our first one, our largest exponent is 4th degree, which is an even, and the leading coefficient is positive, so we know we're looking at up and up. So I think in your work it says rises to the left and rises to the right, but you get the idea, right, by the directions of the arrows. On the second one, our degree is 5, which is an odd, and we have this negative leading coefficient, so odd negative is decreasing. So rising to the left and falling to the right. Now, if you have trouble remembering these rules, the easiest thing to remember is do the simplest form. So an odd is a linear, right? Linear is the simplest odd we could have. So if we have a positive odd, it looks like this, right? It's linear. If we have a negative linear, it looks like this. So you notice that the end behaviors for any odd would look the same as linear. And then likewise for the simplest even, a positive even is a parabola, which is up and up. A negative parabola is down and down. So we can use these to guide our thoughts, or guide our problem solving. Okay, the last one is a little bit harder to find the degree, but it's not too bad. So we have this squared on the x. So we're going to apply that. So x squared. Then we have one more x, and then another x outside. So altogether we have 2 from this last part, 1 here and 1 here. So altogether we have x to the 4th. Our leading coefficient is positive. So what we're going to have here is a positive even degree. So we know our end behavior is up and up. Okay, on to the next one. It's saying f of x equals negative parentheses x plus 1 squared times x minus 2. And it's asking us, where do the zeros cross, where do the zeros touch, and what is our y-intercept? So remember, cross is any odd power factor. So because this is x minus 2 to the 1 technically, right, because we have one of them there, then this is going to cross. So it's going to cross at the 0 for x minus 2 is 2. Now anytime we have an even exponent, it's going to touch. So it's going to touch at -1, which means that if this is our x-axis, it's going to come to the x-axis and bounce off. It's going to come to the x-axis and bounce off. It's not going to go through the x-axis. Okay, and lastly, x-intercept, that's pretty easy. Remember, x-intercept from Algebra 1 just means find the f of 0. So we're going to plug in our 0. So we have 1 squared is 1 times 0 minus 2 is -2, which is positive 2. Okay, number 4 is asking us to match the graph, but we're just going to talk about what we're looking for when we're matching the graph. So notice for this first one, this is degree 3, and we have a negative leading coefficient. So we know the end behavior, right? So let's determine the end behavior. And we know that odd negative looks like this, right? Because we know an odd is like the linear, and because a negative linear decreases from left to right. We know our end behavior. Okay, we also can find our zeros. So in this one, it's a little bit different. There's not like 3 or 4 different parts. Notice that we have x's in both of these parts, right? And we can also take out a factor from 2 and 8. So let's do all that in one step. So we're going to take out our common factors, which is negative 2, and we can take x squared from both of those terms. So when we do that, we're left with, in the first part, if we take out the negative 2 and 2 of the x, then we just left with 1x. And in the second part, when we divide out our negative 2, we get negative 4. And because we took both x squareds out, we don't have any x. Or we took both x's out, we don't have any x. So this is going to be our factored form. So notice we have a 0 here. So zeros. We have one at positive 4, right? Because 4 minus 4 is 0. And because we don't have a power here, or actually the power is 1, we know that this goes through. So this crosses through the x-axis. And then we know here, because we have x squared, we know if I plug in a 0 there, or if we plug in a 0 there, then it makes the whole first part 0. So we have a 0 there, but because it's squared, we know it bounces or touches. Okay, so we could even sketch this graph at this point, and if we can sketch the graph, then we can definitely figure out which one is the correct graph. So let's kind of draw this here. We know we have a 0 at 0. We have a 0 at 4. From here, we're going to do our end behavior, so we know it looks like this on one side and this on the other side. We know at 0 it bounces, so it's going to come back up like this, and then at 4 it crosses through. So we're looking for the graph that looks like this one. Okay, let's do the same thing for the second one. H of x equals x plus 4 squared times x squared minus 1. So one of the good things about this one is it's already in factored form, right? But what we can do is we can factor the second part. I'm not sure why they didn't factor that part since we're doing factored form, but this is good practice. Notice anytime we have a perfect square here and a perfect square there with a minus in between, we can rewrite that as x and then the square root of the last term, and it's going to have a plus and a minus in there. Right, so we have x plus 4 squared, and then x plus 1, x minus 1. All right, so let's talk about end behavior. So our end behavior is going to be, we have 1, 2, and then this squared x, so that's degree 4. So end behavior. And notice that we don't have anything in front, which means it's positive. So we have positive even, which is up and up. And then we also have our 0. So we have our 0 at negative 4. This one is going to bounce because we have an even exponent. And then we have negative 1 and positive 1. And these are both going to go through the graph. Okay, so let's kind of sketch this out. 1, 2, 3, 4. That's -4, -1, and +1. Okay, our end behavior, so these are the two ends, and then our other one is at -1. So from the ends, we know it's going to go up here, up there. We know that at -4 it's bouncing, so it's going to come off our graph. It's going to go through at -1 and through at +1. So we're looking for this graph. Okay, and then on to the last one, and I wanted to do this one. It shouldn't be too hard, but in case we forgot what this looks like, it's asking us where is it decreasing. So it's decreasing all the way in here, so from -infinity to whatever this point is, let's say A. Let's say this is B. So from B to C. Let's call this D. So it's decreasing from D to E. And then from, oh, okay, that's it. So there's no more U. Okay, where are local maxima? So any place we have the top of a hill or bottom of a valley, we call those local maxima. So we just list all these points, A, B, C, D, and E. What is the sign of leading coefficient? So remember, leading coefficient tells us about our end behavior, right? So we know about this because it's up and up. Not only do we have an even degree, but also that it's positive. So sign of leading coefficient is positive. And then possible degree. So here's where it gets tricky. We do know we have an even degree, but we also know that if we have something curvy like this, the amount of times it changes direction can be, well, it's got to be, our degree's got to be one higher than that at least. So let's say we have 1 change, 2 change, 3 change, 4 change, 5 change. So it's possibly a degree higher than that, so it's possibly 6, but it's also, because in your assignment it lists a bunch of them, it could also be 8, it could also be 10, it could also be any higher even value, because this is an even graph. So just be careful when you answer that. We don't just answer 6. Like 6 is probably the most common one, because that would be one higher than the number of turns that we have, right, or the number of maxima, but that's not the only one. There could be higher degrees as long as they're even to match the graph. Okay, that's it today. Hopefully this review helped you remember a few things. Maybe you learned something for the first time. That's awesome. Good job.